Hello students, and welcome to today's lesson on extraneous solutions. Our objective today is that we will identify extraneous solutions of rational functions using journal notes and previous practice problems. So the last few days we've been talking a lot about finding the solutions to rational functions, right? We have to find this least common denominator, multiply everything by the least common denominator, and then solve as we would normally. One of the things that's happening is we're actually creating more solutions than actually exist. So the algebra isn't quite giving us numbers that work in every single situation. So we have to go back through our problems and comb through them and make sure that all of our solutions are actually solutions. So really this process that we're talking about is just plugging in our answers. So to solve for extraneous solutions or identify extraneous solutions, we're just going to plug in answers to the original equation. All right, so I want to go back to number 2 from 11-6. So number 2, (11-6). And this problem is it's going to be x plus 6 over x is equal to negative 5. And what we found is that our solutions to this could potentially be x equals negative 2 or x equals negative 3. Okay, so we plug in each of these numbers and we see if they work. So we plug in negative 2. So for my first x equals negative 2, I plug in negative 2 plus 6 over negative 2 is equal to negative 5. Okay, so this will be negative 2 plus negative 3, and that indeed is going to equal negative 5. So we know that this is good. So now we plug in x equals negative 3. So here we'll see negative 3 plus 6 over negative 3 is equal to negative 5. And again, what we're going to see is that it's going to be negative 3 plus negative 2, and this will work again. So it is equal to negative 5. So extraneous solutions are pretty rare, but we do need to go back through and check. So that's all that we're doing. Whenever you get an answer for these rational functions, you need to go back through and make sure that that solution actually exists. All right, so let's just do another couple of practice problems. So we have 2/3 plus 3x minus 1 over 6 is equal to 5 over 2. So again, we're going to want to find a common denominator for all three of these denominators. And we're going to find that the least common denominator is going to be 6. So we need all of the denominators to be equal to 6. So we're going to multiply everything by 6. So we have 6 times 2 over 3 plus 3x minus 1 over 6. And then on this side we have 5 over 2, and that's going to be multiplied by 6. So this will end up being 2 times 2 is 4, right? Because the 6 and the 3 cancel, and then doubly so, the 6 and the 6 cancel. So we have 4 plus 3x minus 1 is equal to, and then over here again, these will cancel, and we're left with a 3. So 3 times 5 is 15. So then we have 3x, and then 4 minus 1 is going to be 3, is equal to 15. We get 3x is equal to 15, and then x is equal to, 3x is equal to 12, and then we get x is equal to 4. So we have to take this 4, and we need to plug it back into our original expression. So we have to come back up here and plug it in. So we have 2 over 3 plus 3 times 4 minus 1 over 6, and that should equal 5 over 2. So we get 2 over 3, and then 12 minus 1 is 11. And, oh wow, look at this. So, and then we were saying 5 over 2. So we're going to have to change our fractions again here. So 2 over 3 is going to be multiplied by 2 so that it matches. So this is going to be 4 over 6 plus 11 over 6 is equal to 5 over 2. And that's going to end up being 15 over 6 is equal to 5 over 2. And then let's divide both of these by 3. So we get 5 over 2 is equal to 5 over 2. So 4 is a valid answer. So 4 is valid. And we can box it. All right, and then let's do this next example. So it looks like our common denominator, our LCD, is going to be 10. So we want to multiply everything by 10. So 10 over 5 will give me 2, so it's 2 times 3y. So these will cancel, and then those will cancel, so these will end up being, you have 2 times 3y plus, now it's going to be 5 times 1, so 5 times 1 is equal to y. And so you have 6y plus 5 is equal to y. And we're going to find that if we subtract, we get that 5y is equal to -5, and y is equal to -1. So now we need to take that y equals -1 and plug it back in. So we'll plug it back in here, and we get 3 times -1 over 5 plus 1/2 should equal -1 over 10. So this is going to be -3 over 5 plus 1/2 is equal to -1 over 10. So I'm going to multiply both of these numbers by their, I still have this LCD of 10, right? So I need to put everything in tenths. So I'll multiply this by, so that's -6 over 10, and this is going to be plus 5 over 10. And again, we're going to see that this is -1 over 10. So -6 plus 5 is going to be -1. So we have verified that y is equal to -1. So what we're going to go and do today is we have 6 additional practice problems, but first what I want you to do is come and make sure that you have all of your solutions correct for 11-6.2. And then what I want you to do is go back through 11-6.2. There's only, I believe, 12 problems there. And all of the ones which have a numerical solution, you need to go back through them and verify that those numbers will work and that those are actually solutions and not extraneous ones. All right, so your reflection today is we're just going to go ahead and ignore this part. We're not going to think about where they occur. We're always going to check for them. But we do want to think about how we check for them. So your reflection is to tell me how we check for extraneous solutions, and then your assignment today is to go back through 11-6.2 and verify that all of the solutions are really solutions. Have a wonderful day. If you have any questions, let me know. Goodbye.